In the previous presentation, we heard about the distributed nature of the open science grid, which connects researchers to globally shared compute power via local access points. And it's this idea of being able to submit locally but run globally that really drives a lot of how we think about the open science grid as a tool for accelerating research. HTCondor is the software that makes all of this possible. It not only creates and manages the distributed high throughput computing environment of the open science grid, but it's also the tool that enables users to execute their high throughput computing work. In this presentation, we'll discuss how to submit jobs using HTCondor, and we'll also introduce a couple of different features within HTCondor for enabling high throughput job submission, as well as briefly discuss a couple of different options for workflow tools that can be used within the open science grid for managing more complex workloads. To schedule a job with HTCondor requires a submit description file. On the left-hand side of our screen, we're seeing one such submit file that we'll use for this example job submission. This is just a plain text file that defines everything that HTCondor needs to know about the job. And I'm going to walk us through a couple of the different things that are described in this file. So the first 3 lines here, the executable, arguments, and transfer input files, essentially describe what the job will run, along with any parameters that are going to be used to modify how that work is performed, along with additional files that will be needed for this job. So the executable in this example is a bash script, but it could also be a precompiled binary that you need to run. In this particular case, we're going to modify how this script runs by including a flag along with specifying an input file that's to be used. And then we have to use transfer input files to tell HTCondor what files are needed in addition to the executable to run this work. One thing to briefly note is that the executable will always be transferred with the job to wherever it runs, but then anything else that's going to be needed should then be included in transfer input files or use one of the other transfer mechanisms based on those files. And that's something we'll talk a bit more in the next presentation. So these 3 lines together are the equivalent of running this example command in your terminal. The next 3 lines in this submit file define 3 files that will get created for the job. Those being the error and output files, which are where the standard error and standard output from the executable will be saved. And then the last file, this log file, is generated specifically by HTCondor, and various events that HTCondor is performing or observing with your job get saved into this particular file. So these 3 files combined are really important for troubleshooting any issues with your job execution, or just learning a bit more about where your jobs ran, what amount of resources they used, etc. So these are always files to keep on hand as you're performing job submissions. The next 3 lines here explicitly define the resources that are needed to perform this job. So there's a request for the number of CPUs, which is really a request for the number of cores, a request for the amount of memory, as well as the amount of disk. And this is on a per job basis. And this information is helpful, or is important for HTCondor to find the execute nodes that are able to run your work. And so really these details are going to steer your job to the appropriate resources that are available. And this last line here in the submit file is a keyword that generates a job. And in this particular case, but the way that this queue statement is set up, this job will submit one job, but there are other options that we're going to look at in a moment that enable you via this queue statement to submit multiple jobs, all with a single submit file. Okay, so once you have your submit file set up, you would use HTCondor command, condor_submit, provide the name of the submit file for that job, and hit enter. And at that point, HTCondor takes over managing the job, finding the appropriate resources to perform that work. And so what happens is, this process would occur on your local access point, and then the executable file and any additional files specified with input files will get copied out to one of the execute servers that is available to perform that work. And on that execute server is where the work will be performed. When the job is finished running, any output that gets generated along with the standard error and standard out will get copied back to your local access point, making those results accessible to you. And that is the general overview of the life cycle of a job submission. Okay, so one of the really great features of HTCondor is the ability to submit multiple jobs using a single submit file. So I kind of indicated this in the previous example that we saw, where in our submit file, we saw the word queue followed by the number 1. So in this particular case, this submit file will submit one job. This format shown here, where we have the word queue and a number, is one way to submit multiple jobs by providing a different number. So for an example case here, if you had the word queue followed by the number 100, this would submit 100 jobs. And each one of those 100 jobs in this batch will get assigned a unique number, what is referred to as the process number within HTCondor. So the first job will by default get assigned the process number 0. The second job will get assigned the process number 1, and so on all the way to 99. Now, what's not immediately obvious is that you can use this process variable anywhere in the submit file to convey this unique number as a bit of information about the job. So for instance, you might want to pass it as an argument to your executable. This provides one way of kind of customizing what happens for each one of the 100 jobs. In this particular case, you could use this argument as a way to create uniquely named output files, where each output file has this process number in the file name. There are other options here. Common use cases for this particular option include doing like replications of some amount of work, or one of the examples I often come across is perhaps like a parameter sweep, where the process number specifies a row in a table from which the job will pull information like parameter combinations. And then by passing this number as an argument, the job knows which row in that table to look at and to use for how to set up the way that job runs. So there's a lot of flexibility here. It's not immediately obvious. It's kind of easy to overlook, but this is a nice option to use for multi-job submission. What we perhaps see more often, though, is the use of this alternative multi-job submission scheme, where we have the word queue followed by some defined user-defined variable name. In this case, in file will be our variable name. And then from a list or matching to some set of file names that match a pattern. So in this case, it's very much like using a wildcard to list out files that end in .dat. So in this example here, in this particular case, there are 3 .dat files. Each one of those files is listed in a separate text file, one file per name, or sorry, one file per line, one file name per line in that case. And then what happens in this particular case is that this in-file variable for each one of the jobs will equal this particular file name. So the first job that gets submitted here, in-file will have the name a.dat. The second job in dash file will have the name b.dat, etc. And then, like our previous example, you can use in dash file as a variable anywhere in the submit file. So what this is often used for is performing a pipeline on different input files. So you would use this then in transfer input files. And then this way you're essentially looping through your set of data sets or sample files that you have. And this is a really convenient option to use. One thing that's not clear, immediately obvious, I should say, in this example is that you can create multiple variable names to use anywhere in the submit file. So this bottom example is, again, it's defining two variables, X and Y, that are defined in a separate text file. And you can use them, you can use them as arguments to pass to the executable. And I think what I'm trying to emphasize here is there's a lot of flexibility in what you can do with this particular setup. And I often recommend to users, if you have sample files that are different sizes and you need to kind of maybe bin them based on how much disk to request for a job, you could use this this setup to essentially assign an amount of disk or an amount of memory to request for each one of those separate, say, input files that you have for your job submission. So these are just a couple of ways in which you can leverage HTCondor multi-job submission features to accelerate your job submission. But it's very convenient. It's a lot easier to manage one submit file rather than hundreds or thousands or maybe even millions if that's how many jobs you need to submit. Okay, and I just want to also briefly touch base on a couple of workflow tools that are available within Open Science Grid to help manage more complex workloads. So users have a lot of options available to them. Within HTCondor is the DAGman, or directed acyclic graph, which is an option for describing job dependencies within your workflow. So if you had a set of jobs that needed to run before a second set of jobs could start, you could use DAGman to describe those dependencies and execute the workload as you define them. Pegasus is another tool that's pretty commonly used within Open Science Grid. It builds off of DAGman and provides some additional functionality on top of that. There are two other sort of make syntax-like workflow tools known as Makeflow and WorkQueue, which are also available. And then within Python, there's the Parcel parallel computing toolbox. And then on top of that, the HTCondor Python bindings are available for streamlining the interaction between HTCondor and Python work that you may have. And so I'll take any questions.
All right, thanks, Jess. There was a question in the chat about if you could go back to your matching slide. Yeah, about if you can use, like if you use star.dat, does it look in the current directory? Can you provide a full path if the DATs are located elsewhere?
Yeah, that's a good question. This particular example is going to look in the current directory from where you submit the submit file. I actually I've never tried to specify another file path. I would think that that's an option, but if someone else on the team could chime in more definitively.
Yeah. So yeah, Condor assumes that the files you list in the submit file will be found relative to your submission location, meaning the location you're in when you type Condor submit to submit the job. But you can give full paths to files. And because it's relative, you can say it's one directory up or it's down in this directory. Or you can specify a different, what's called initial dir as another option in your submit file that forces Condor to use a particular location or relative to your submission location, a different directory from which it expects to find other files.
Yeah,
it's
so
completely controllable by you as the user in the submit file.
Yeah, so any of the file names can include absolute or relative paths. I just personally haven't used this matching feature to point to another subdirectory space, but it does sound like that is an option, which makes sense knowing what I know about, you know, setting up a submit file in general. So yeah. Are there any other questions worth touching base on?
Somebody asked about Parcel, if I'm pronouncing that correctly, which looks to be a Python library for parallel scripting. And while I haven't heard of it before or looked into it too deeply, I will say that there are a number of libraries that do parallelization within a Python job. That's more of like an HPC approach, like you expect to do a single Python execution and have, say, multiple cores be distributing work. If Parcel is more like a workflow tool, then it's possible that it works with HTCondor, and not just in the context of OSG, but other Condor systems. What can sort of determine outright whether a workflow tool does or doesn't work well in OSG is whether it expects to have a shared file system across all of the jobs that are running. Some workflow tools expect a more HPC cluster type environment, specifically with a shared file system. Other questions? How is Condor different from Bosco? And I actually might defer that one to office hours tomorrow. There's a room specifically about Condor and building local HTC capacity, where that question might be better answered. But Bosco is a tool of Condor. So it's within the Condor software suite. And therefore can do a fair number of the things that Condor does, but it really is sort of part of the Condor software suite. How do you get output data files generated by the executable back from jobs? That's another great question. By default, output that's created in the top working directory of the job gets transferred back to the submit point. And I believe Mats will talk a little bit about that as sort of the default mechanism of how data gets back. You can specify that you only want certain files back, but it's a little more foolproof to just make sure that the only files left in your working directory at the end of the job that are newly created or modified are the ones that you do in fact want back. Namely, if you tell Condor that you want a certain file back and it didn't get created during the job, Condor can't really help you there, and so you won't get that output back. The submit file didn't mention OSG specifically. Where would you specify that job to be on OSG versus a different platform? So we're assuming in this case that you are submitting jobs on an OSG access point, meaning that by default, your jobs are going to run on OSG. And I'll talk a little bit more that the OSG Connect service that some of you have test accounts through for this training submits into what we call our open science pool. I'll talk about that, but there's no need to specify that you want to run an OSG. If you have a local campus access point and it can submit to multiple places where OSG is just one of them, it is completely configurable on that submit point to have flags that your users can specify to say that they want their jobs to go to OSG or not. And we do that at UW-Madison. One more, does HTCondor by default return the job output files to the same directory as the submit file? Aha, another good one. So yes, by default, output that was created in the working directory of the job on the execute server gets transferred back to the submission location. Again, that's unless you specify an initial dir that's different. And that initial dir can be different for each job if you want, so that you could have output from different jobs coming back to different folders on the access point.
Yeah, to add to the answer there, John, the second option is what you've written is correct. It's whatever the current directory was when you ran Condor submit, not necessarily the folder that has the submit file, which is usually it's the same, but not always.
Yeah, as the user, you can choose for those not to be the same.
Yeah.
So again, just like
yes, a few comments. One is I want to stress that in HTCondor we are working hard to support large ensembles or sets of jobs, because that's what high throughput computing is about. So you should really think about the access point as a database to manage large number of jobs. We have situations where a single access point has hundreds of thousands of jobs that are being managed, and some users may have very large ensembles like this. So if you think about everything you heard until now, it is an attempt to make it easy on the user to manage large ensembles of jobs. And as far as redirecting and mapping the input sandbox and the output sandbox, there are pages and pages in the HTCondor manual about all the options that you have in terms of directing and redirecting. The default is that it goes from the access point, the input sandbox, and the output sandbox comes back. But I will strongly encourage you to contact the facilitators when you have other scenarios of where the input sandbox or the output sandbox of the job resides.
Yep.
There are many, many options.
And that's a great point, Marone, and one that I'll emphasize later when we talk about slightly more advanced capabilities via OSG and through HTCondor. In particular, Condor can negotiate S3 transfers, so it can transfer data to and from AWS between your jobs so that you don't have to stage it on the access point. It can do HTTP downloads and manage those for you with automated retries, et cetera. You'll hear about a couple of these options that we promote as sort of the simplest set for users to take advantage of through the OSG Connect set of access points. But there is certainly a lot out there that also makes Condor useful beyond the OSG, but inclusive of it.
And I would say, so you better understand our mentality, we encourage you to come to us and ask for things that we don't do. I don't promise that we'll do them, but at least we will know that there is somebody out there whose life can be improved if we can support it. So please don't just look at what we do, but go back to the facilitators and say, I wish you could do this. This is very valuable for us.